So here's some multiplication that we already know how to do. And we remember that we always, when we multiply, we do x times x, x times 7, 5 times x, 5 times 7. We combine our like terms, we get this. Now, what we want to do is make some observations. And what I observe is that this first term, that first term, look, it's x squared. It's always x squared. Okay, as long as these two are just x's, one x, not 2x or 3x, the first term is x squared. The second term, where does this term come from? This term comes from this and this being added, right? This is 5. This is 5 plus 7. That's 5 plus 7, right? And then this term over here, right? This is also happens to be 12. That's 2 plus 10. That's where that term comes from. Look, why did it happen like that? Because this ended up being 7x, this ended up being 5x, we added them. Okay, so that makes sense. And then where did this term come from? Right? This term came from those same two numbers being multiplied, right? This was 5 times 7, that's where I got this 35, and it came down here. So this is 2 times 10, that's 20, it came down here. So the second term is the sum, right? Remember that means added. Okay, and this third term, the third term, is the product. That means that these two numbers were multiplied to get that third term. So here's the thing is we can take these observations that we've made about multiplication and we remember, oh yeah, factoring is just the opposite of multiplication. So if factoring is the opposite of multiplication, then I know that when I'm looking for two numbers, I'm looking for two numbers that multiply to 30, that multiply to the third term, right? Because that's what happens. And those same two numbers need to add to the second term, right? So I'm looking for two numbers that, in this case, two numbers that add to 11 and multiply to 30. Over here, I'm looking for two numbers that add to 10 and multiply to 25. How did I know that's what I'm looking for? Because I observed in multiplication that that's the pattern that happens. So here, in this case, two numbers that multiply to 30 and add to 11, that's 5 and 6. And two numbers that multiply to 25 and add to 10, that's 5 and 5. Okay, now, we're going to come down here and we're going to do the same thing. We're going to observe. Now, here's the difference. There's a really important difference. And the difference is here. See how this is a 2x? This is a 4x. This is a 3x. This is a 5x. That's new, right? Here we just had 1x, 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 1x. Everything was 1x. So now here we see, okay, this time the multiplication is the same. The process is the same. 2x times x is 2x squared. 2x times 5 is 10. 3 times x, 3x. 3 times 5 is 15. Okay, so we can see the process for multiplication is the same. We're combining like terms. The two like terms are always land in the middle if we do the multiplication in the same order. So the multiplication looks the same. Now what we're going to do is we're going to make some observations. And you notice I've left out the second term here. And the reason is the second term, it's a doozy. Okay, there's not like a really clear observation about it. But there is still a really clear observation about this first term in each expression, in each answer. Okay, and the observation is that that first term, this first term, where does this come from? Think it comes from right here, right? It comes from multiplying this times this, right? 2x times x, that was 2x squared. 4x times x, that was 4x squared. 3x times x, right? That multiplied, I got it here, brought it down, 3x squared. 5x times x, that becomes 5x squared. So this first term comes from multiplying the x terms. Right? It comes from multiplying these two terms. So that's where that first term comes from. Now, the third term, this term, where does that come from? Well, let's look, right? The 15 came from right here. It's coming from above. There's no combining like terms that's happening. Where did this 15 come from? Oh, it came from 3 times 5. Where did this 18 come from? It came from 2 times 9. This 14 came from 7 times 2. And this 2 came from 2 times 1. So where does this third term come from? It comes from multiplying the terms without the x. Those are called the constants. The constants, right? These are constants. 2, 1. Terms without an x are called constants. And we multiply those constants, we get this constant at the end. Okay. Now, we've made these observations. Same as before. Remember, we made observations about multiplication, and then we use those observations to work our way backwards in factoring. We're going to take these observations, and we're going to use those observations to work our way backwards in factoring. So here is what I'm looking at. Now, this is tricky, and you have to be patient. I'm going to set up my factoring. Okay, now here's what I know so far. I know that this 3x squared, now remember, right, I'm doing the opposite of this. So like here, for example, I did 2x times x, I got 2x squared. So now in this problem, I'm looking, I'm saying, 3x squared, what would I put, right? I know that this first term comes from multiplying the x term. So I'm going to put a term here and a term here that multiply to get 3x squared. Now, I know that to get 3, I can only multiply 3 times 1, right? 3 times 1, I'm not going to write the 1. And to get x squared, it's x times x. So I'm going to multiply 3x times x. 3x times x, that's going to get me 3x squared. Okay, 3x times x, that's going to get me 3x squared. Now, I'm going to put 2 plus signs here. And in this case, I know it's plus signs because everything here is positive, and you'll notice everything today is positive. We're not going to see negatives until tomorrow, okay? So everything's positive. Now, here's what I know. These two numbers, remember, our other observation was that these two numbers need to multiply to this. So what are numbers that multiply to 15? Well, I only have 2 possibilities, 1 times 15 and 3 times 5, okay? So here's the deal. The only way to figure out which is correct, there's actually 4 options, right? 1 and 15, 15 and 1, 3 and 5, 5 and 3. And only one of the options is correct. How do I figure out which one's correct? I just guess and check. Here's what I mean. Let's start with 3 and 5. I'm going to put 3 right here and 5 right here. Now, here's what I want you to notice. Look, I'm going to write really dark. I'm going to go over this really dark 3x plus, I'm pushing down really hard, x plus. That stuff's not going to get erased. That's for sure going to be there. Notice I wrote this 3 really light, and I'm going to write this 5 really light. Here's why. Let's check and see, right? Remember, I just factored. I did the opposite of multiplication. Let's multiply to see if I get this. So 3x times x, that's 3x squared. I already knew that, right? Because I set those in stone, and I knew they were going to multiply to 3x squared. This 3 times 5, I know it's going to multiply to 15. So that's not what I'm checking. What I'm checking is this, the 14x. So here's what we're going to do. 3x times 5, okay, that's 15x. 3 times x, that's 3x. When I combine these like terms, I'll get 18x. Is that this? Nope, that doesn't work. So cross it off or erase it, whatever you want, and say, okay, 3 and 5 didn't work. Let's try something else. Let's switch them. Let's try 5 and 3. Okay, so now I'm going to try this situation. Now notice the 3x and the x are still in the same place, so that's still going to get 3x squared. These are still 2 numbers that multiply to 15, so that's not changing. The only thing that we're moving things around, the only thing that might change is this. So let's see. When I do 3x times 3, I'll get 9x. And then 5 times x, that's 5x. And when I combine my like terms, 9 plus 5, that's 14x. Oh, hey, that's what I want it to be. So I got it on my second guess this time. Pretty lucky. I'm going to go ahead and darken those and box my answer. That is my answer. If I were to multiply this out, I would get this. So that's factored. Let's do one more. Okay, I know that these two numbers will multiply to 5x squared. 5 is prime. The only way to get it is 5 times 1. So I know this is going to be 5x times 1x. Okay, and watch, I'm going to erase that one. That one is silly. We can just write x. Okay, and I'm writing these nice and dark. These are not going to change. I'm going to put a plus sign right here. Now, here's where I get to my guess and check. Okay, now 16, look, I have 1 times 16, 2 times 8, 4 times 4. These are all possibilities. Okay, so let's try. I'm going to start with 4 times 4. Okay, and remember, right, I know that this number comes from these two numbers being multiplied. So I know that these two numbers have to either be 1 and 16, 2 and 8, or 4 and 4. Okay, so let's start with 4 and 4. Nice and light. 5x times x, remember, that's already 5x squared, so I don't need to try that every time. And this is already 16. I don't need to try that every time. What I'm trying is these two. So 5x times 4, that's 20x. 4 times x, that's 4x. That's 24. Is that what I want? Nope. So that doesn't work. Look, I'm going to cross off 4 times 4. Okay, and then erase, right? I made it nice and light so I could erase. Let's go on to trying 2 and 8. So I'm going to go start with 8 and 2. Okay, so 5x times 2, that's 10x. 8 times x, that's 8x. I combine those, I get 18x. Is that what I want? Nope. That doesn't work, so let's switch them. And notice I'm kind of keeping track of what I did. I crossed off the 4 times 4. I tried 8 times 2, and now I tried 8 and 2, and then I'm going to switch it, and if it doesn't work, I'll cross this off. 5x times 8, that's 40x. 2 times x, that's 2x. 40 plus 2, that's 42. Oh, hey, that is what I wanted. So I'm going to go ahead and darken it. Looks good. And that's my answer. Okay? Your turn to try. Trust yourself to try it out. Reference the examples, but trust yourself to just try it and see how you do.